Welcome to the first lecture of Unit 2. You know from the assignment schedule and from the syllabus what topics these are. Now that you've had a brief overview history of agriculture in America and a little bit of the background of how America was established on agriculture and how we grew, you know a little bit about how civilizations and societies formed. We're now going to begin to delve into particulars, and with this particular food security, food insecurity, and the factors influencing and surrounding food security that we must consider in solving food insecurity, we begin with population. There's nothing more appropriate than discuss agriculture's grand challenge, as has been published in papers such as Crop Science, but first let's introduce this idea of what is a society. A body of individuals living as members of a community. So that could have been hunting and gathering, agriculturalist, such as pastoralist or horticulturalist, plants and communities. So we kind of saw from the first unit what a society is and how societies developed. But let's just, as a reminder, it's a body of individuals living as members of a community, and each of those people have needs individually and communally. And of course, one of those primary basic needs is that of food to live and for survival. So successful societies must address the needs and wants. There is a psychological or mental capacity. If we're not getting certain desirables, we get upset, we get disgruntled. It affects our attitudes and our perspectives of the world and the people around us in the community. And so for a peaceful community, there's reasonable wants and there's necessities that must be met. So the basics: clean air, right? We got the Clean Air Act. We need oxygen to live, water, clean water, food, clothing, shelter. All this comes from the environment. All this comes from those goods and services that only the environment can provide with us. So we must take care of that environment in order to get these things back out of it. Plus, as I was just mentioning, other psychological human needs. For instance, certainty. We make plans. We like to know. If you have a check, an income, you budget to make sure certain needs are met. You're going to need transportation. That's going to take money for gas. Of course, eating every day, preferably. Make that a good point. When you eat every day, eat a variety of foods every day, right? So we want that certainty. No child likes to go to bed hungry. With the uncertainty, the mind goes into a survival mode, and that makes life and learning and productivity rather low if you don't know or you have certain uncertainties in your life. Safety is another big one. Variety, significance, connection with others, growth, contribution. These are psychological or human needs as well that must be met. This class, of course, is not about those, but obtaining oxygen, water, food, clothing, shelter, these things help secure certainty and variety and significance. So in achieving those basic needs and wants that every individual in a society keeps us at rest and peaceful, the only reason we don't war as much as we do is because, generally speaking, at least here in America, a well-developed nation, we don't have those uncertainties and insecurities en masse. So another issue arises as we begin to supply, and I don't intend to lecture, by the way, through all this slide set. I'm just giving an introduction, and then I'll fly through the slides telling you what is there. I just want to introduce this topic, I should say, over these first 7 or 8 slides. So for this growing world population and the things that we're able to do to provide for and to live in community has had its toll. It's had its toll. And here in a report by McGill University A group of scientists here published a paper fairly recently, and they say over the past 40 years, human well-being has been steadily improving, while natural ecosystems from which we derive many goods and services have been declining. So when we talk about goods and services, what we're talking about is, say, in goods, that's the fresh water, food, much of our fuel, wood for lumber and paper, leather, furs, raw materials, fabrics, oils, alcohol, so many things. When I talk about services that the ecosystem provides, that support human life and economic well-being, or like breakdown of waste, good soil microbes, fungi. You also have scavengers, regulation of the climate, the amount of trees or plants or grasslands, erosion control, pest management, maintenance of crucial nutrient cycles, and so forth. So these are services that the environment can provide without them. And that's besides, of course, the mental things, as we all like to get outdoors from time to time. And some of us choose to work outdoors just because, we love them so much and being out in the elements. Now, this is kind of, this statement is generally true. So the question is, how can we continue to improve without harming or decimating the very thing, the environment, that's allowed us to improve? The sustainability of being able to continue to improve without destroying, as a matter of fact, maybe even enhancing the environment, becoming stewards of the environment as well as humans. In response to these, there's 4 trends we will consider over the next 4 weeks. And today, starting with this PowerPoint and the next, is human population and well-being. We'll discuss that around the world. Number 2, the status of vital ecosystem services. So we'll look at the renewability and sustainability of our water and soil, food, from which our soil, because that's where our food often comes from, and then timber, fiber, fuel, as is listed there. We'll consider global climate change at the end of this unit, and loss of biodiversity. At the moment, I don't remember if that's in this unit or Unit 3. I believe, well, we'll make reference to it anyway here. So these are the 4 things for the next 4 weeks we'll be looking at. No specific time for them, but all in all, each of these will be discussed as we go through it. But today, this week anyway, looking at human population and the status of vital ecosystem services. So when we talk about population, there's a guy back in Darwin's day, or a little before Darwin actually, and it's the guy from whom Darwin drew a lot of his ideas, so to speak, or acted as a fuel for his ideas. And that was that populations will always increase faster and ultimately greater than what the environment can provide, which means that eventually all communities or populations will top out at a certain number, at which we call that carrying capacity. That's the carrying capacity of the environment. If you've taken biology or ecology, this might sound familiar. So there's a carrying capacity that a particular environment or ecoregion can support. And once all the habitat, food, water is being consumed and protected that can support, the population no longer grows but stays kind of at that steady flux with what the environment can support. So in an essay on the principle of population, he says even of humans, that world population will eventually increase to a level that cannot be sustained, resulting in famine, war, and disease. And so when you look at this arithmetic, that is 2, 4, 6, 8, 10, 12, that's what it would look like as a straight line if it just went by a replacement value where we added 1 each time or added 2 with each, say, generation that passed on. But we don't see that. Most organisms tend to form a curve, this geometric ratio or exponential ratio that slowly climbs over time and then dramatically just, and this is indeed what we see in our own time now, very visible. So as he says, then it's inevitable. Famine will occur. So here are some historically significant famines that are recorded in history, and some of those fairly recently. If you look over here in the bottom right hand, well, actually all these here, yeah, 1900s, 25 to 30 million in China each time. That is a humongous number. These famines, as a result of either drought or no growth or locusts or whatever it might be, pests, wipe out a large amount of the food supply. And that's a large amount of the population that depends on that food supply, of course, goes in need. Some of this might be due to the fertility rate, having a very high fertility rate, and can't support the population. Maybe they have food, but it's just not enough food to support the number of babies being born per year. So there are quite a few here. You can just look through this list. There's nothing you have to memorize or remember, but I think it's pretty significant to note that famines will occur on a regular basis. And so how do we prepare for those famines? I think of the story of Joseph. If you're familiar with the book of Genesis and the wisdom of Joseph to begin to store up grain when he was alerted that there'd be 7 years of famine in the land. And so when we can learn these weathercasting and forecasting models that show something as powerful as that, given no divine intervention as Joseph had possibly, to see this famine coming, we can prepare. And now, of course, with our technology and modern science, we have been able to build seed banks and germ plasms, which we'll talk about later with the biodiversity topic, in order to prepare for such times. I used to have a slide that showed just how long we can now support, at least in the U.S., and it's not as much as we used to, but it is still a pretty good amount of time. So knowing now then, just kind of taking in Thomas Malthus' model here, that every population will eventually out-eat its resources and therefore hit a plateau at the carrying capacity. When you consider famines occur, starvation is going to be a regular occurrence. And here's where we come in as agriculture. I know several of you are ag majors, whether it be ag business, food science, or horticulture. Agriculture's grand challenge is to adequately feed more people with fewer resources while protecting the environment. So by year 2050, it was said back in 2005, the global population was predicted to reach about 9 to 11 billion people. We're at 7 billion now, or actually I think approaching 8. And this would demand about 50 to 100% more food. You got to think about what that's saying. Either we got to go twice as much food with the same area of land, or we need to dramatically increase our land, which is the very thing possibly that's hurting some of our environment. Maybe something in between would be the best. And there's always going to be compromise. And we like to oftentimes go to extremes, more polarized with our opinions one way or the other. And the person who walks in the middle, while sometimes offers the best solutions that hit both sides, often get chewed out or get knocked from both sides. But it's going to take some compromise figuring out, whether it be growing organic, GMO, for herbicides, so we can grow twice as much, or it's going to be requiring more land or more water. So there's a lot to think about when we begin to think about the demands of this agricultural challenge. Specifically, when we talk about the challenges, it's keeping water quality as well as quantity, soil health, how to grow in the same plot of land over and over and to supply without depleting the soil of its nutrients and health, not only for the plant's good, but just for that soil's life. Loss of genetic diversity, we'll hit that one a little more, like I said. So the biodiversity, If we lose that, we lose what is that original material from which things like corn, teosinte, was made. We talked a little about that in Unit 1. And if a disease, if a virus, if a vector brought in some kind of disease or that wiped out corn, we'd have to go back to teosinte. We'd have to go back to that originator in Mexico where corn was first developed, involved, to find the genes that might allow us to combat whatever pest this was that are destroying corn crops. I don't know if that makes sense up front, but we don't want to lose genetic diversity. Excuse me. Pesticide resistance. Right here is another one. Right here we see the picture. We're going to learn more about this in about 3 weeks from now. This land on the left was managed under a holistic plan versus this one. You can look up holistic if you'd like and see. But the challenges that keep land usable, maybe for cattle, for growing crops, or livestock of any sort, versus depleting it. So these are our challenges: producing enough food to feed 9 to 11 billion people without developing broad pesticide resistance, without losing genetic diversity, while keeping soil health and maintaining water quality and quantity. These are the grand challenges we face. All right. So the agriculturalist, as you'll learn in a future lecture, has the most responsibility. When you think of conservationist, when you think of environmentalist, think of your farmer. Think of the ag industry. This is the front lines of conservation of natural resources. There's a course offered at MSU called Water Conservation and Soil Management. You can learn more about that as well. So as we now go with the rest of these slides you're going to be showing, and you're going to have to get pretty good, take some practice digesting these slides. These are all graphics and images to help you make connections. But this one here is population distribution. Here's a scale or a legend, what those numbers stand for. You can see highly densely populated areas. I want you to kind of overlap some of these maps to see where the population is, where the growing belts are. Look at North Africa, and you look right here in Far East, and then Middle East, coming up to China, through China, Russia. You have it's a dry belt right here, but you overlap this and compare it with other maps, and you begin to see why we have these bare areas and why everybody else lives in these areas. We have a very limited supply of land on which to meet the food needs of the people living there. So here's a hunger map. This is a very positive outlook by the World Food Program they have. Read these bubbles. You'll see a lot of, this is amazing. You can have something like this, South Africa here, which you'll notice, not too bad. And bordered by 1, 2, 3, 4 nations right here that are in extreme hunger. And just kind of compare some of these borders. Now, I'm kind of surprised at Mexico. I would think Mexico would probably be in this brown area, given my knowledge of it. But anyway, this was a 2015 map. I'll trust them. Now, in some of these areas here, India, Middle East, and Bangladesh. Here's some pictures. Kenya, Congo, India. That's in here, up here. I mean, just the infrastructure, the politics, the education, the education. That's the big thing. You can definitely see that we're getting pretty overcrowded. 1 in 9 people in the world. So here, that statistic of 1 in 9 people go to bed hungry is much larger, I'm sure, offset by America, Europe, and other well-to-do. But worldwide, about 1 in 9 people go to bed hungry. The goal is nobody goes to bed hungry. And World Food Program is pretty optimistic that we can solve this. Population changes. So here, natural population growth, this is an excellent. It's more than you could probably have time to read because each part links to another part, but it's a very in-depth. So if you're really wanting to know how they determine fertility rates, death and birth rates, and where population growth is going to be, you do need to at least click on this and skim a few pages of it and a couple links to learn a little more about these population changes, what the trends are. There'll be a video. Now this is slide 12 and you'll have this printout, but there is a video further down. Oh, where was it? I'm looking. Near the end, slide 31, factors affecting population growth. On slide 31, you'll see a video that kind of reinforces at least one or two of the ideas of the natural population growth. But you need to read that, and you just need to see how that interplays in this whole thing. As you go through, you'll have graph about projected world populations, the growth pyramid, male and female, over the next few years, what you can expect to see, where you can expect to see growth. This is, whoa, I gotta get rid of that. Well, when you open up the slide, you'll see how many years it took right here to double the world's population, and then much shorter time. 1800 to 2000 kind of slowed down, but then look at this right here, this trend that's projected. This is really interesting. All right, so spend some time on these slides just to understand them. It's good for your critical thinking skills, digesting these population growth rate by world region. So least developed countries, less developed regions, and then the more developed regions. These are projected growth rates, so it's just saying the percentage at which they are increasing. And you can see that generally the trend is that they're going down, meaning everybody's still growing, but they're growing at slower rates. So the rate at which they're growing is, when you look here, about 1980, 2000, and 20 is going to continue to go down. And that's because of education and the efforts of ag and politicians and those who are aware of environmental issues that we have, making strides towards those. Technology is a big part of that. World population growth is 1750 to 2100. And again, you can see the fluctuation, but notice how right here, the annual growth rate of the world population goes way up as the world population increases right here. This is where you have the biggest jump, right? From in 1900, in just over 100 years, we've gone from not quite 2 billion to 7 billion. High growth rate. As education kind of kicked in, we said, whoa, we're not going to be able to sustain this. I don't know if Earth can sustain this. And you see that annual growth rate of world population went down. Now, why did it go down? Why would the world all of a sudden stop growing? Well, again, we'll see in a few slides coming, but that's the question you want to ask yourself. With each of these graphs, you see trends that go up or trends that go down. You want to ask, how did that occur? What's behind that? It begins to taper off here. This is interesting though, right here. They have 11 billion at 2100. That goes against, right, what that opening slide said, what the grand challenge was. The grand challenge, if you recall, said about 9 to 11 billion by 2050, which is right here if you're following the cursor, 9 billion in about 2050, and 50 years after that, 11 billion. So it kind of goes along with it, but that's a pretty big range. But we will taper off. You might remember Thomas Malthus and what he said. You will hear some varied opinions, and you're going to hear some science that supports each side, so that you know right now I'm not trying to promote a particular view of whether this will occur or not occur. I'll do my best to find sources that kind of not argue, but at least will show you the data for each side and whether or not we're in as dire of a situation as we are. It is a pretty serious situation, but there's a lot of optimism amongst scientists about the future should we change some of the ways we make our decisions. I'm at the 26-minute mark, and I don't like to make these much more than 25 minutes, so this is probably going to run to 30 minutes. heads up. I'm just going to try to fly through some of these. So again, just take your time, notice what each of these lines stand for. Patterns of population change. There's another, this is just a quick video. You can see how the age ranges change over the future as populations grow, the population structure, meaning how many teenagers are in the world, in the different nations, how many teenagers are in the world versus 20-somethings, 30-somethings, 40 to 60, and 60 and up. And you can watch how the structure, of course, climbs to where the average is older people, and then all of a sudden, of course, comes back down. Sorry for the snap of my fingers. Here's a big report. For the first time, Japan's population declines since the 1920s. You got some review questions after you go through these slides. These are the kinds of questions I might put on the test. So you want to be able to answer those from the slides. Spend a little time understanding demographic transitions. Here's your birth rate and death rate. The rate at which, that's a fertility rate, the rate at which babies are born into that region or country, and death rate is, of course, number of deaths. And then here's total population. So look at the, particularly this area and overlap, study it in conjunction with this map, the demographic transition example of Brazil. Mortality rate, fertility rate, again, that's the average number of births per woman, and the population growth rate overall. Again, they're growing, but they're growing at lesser and lesser rates. Then I'll take you through a little detail on one example with India. These slides hopefully are somewhat self-explanatory and stimulate thought, and a couple recall questions to see if you understood those slides. Answers, or at least the references, are in the notes section if you open this PowerPoint up. And then this is a pretty important, very interesting must see. It's about 13 minutes long. Factors affecting population growth, Professor of Global Health in Sweden. You can click on that link and then, of course, answer that question. Oops, there's a typo there. So, as you go and after you go through there, is the Grand Challenge accurate? 2017, that was a couple years ago even, we're now 2020, we're 15 years into the Grand Challenge. 2005 is when it was first stated that the yield increases had to increase by about 100%. Is that still true? Well, new data suggests that crop production only needs to increase by 25 to 70%. Some of the videos I've posted for you to watch are going to address this and explain that coming up. So population predictions are now lower, I'll just tell you, than they were in 2005. And part of it has to do with that reason I was sharing up there. But in the article at the beginning, in this video, everything all together, you have to consider and piece together why it is that population predictions are changing. So it again has to do with technology, plant breeding, and wiser use of our land. But will it be enough of a change soon enough to reverse some of the inevitable disasters? This slide is really the last slide, and it shows that as population has increased, you can see, just as this previous slide stated, food production has been able to keep up. As a matter of fact, we have more food than we've needed to sustain that population. Sad and interesting, though, while the number of undernourished has stayed level or gone down, with excess food, we still have undernourished people. Even more so, the prevalence of undernourishment has gone very much further down, but there are still undernourished people. This is a very interesting question, why we have these two even present still when we have more, let's just say, cereal production than we do people, right? There are some good from this information from this slide to look at as well. I put some notes. Again, if you open this up on your computer, you'll see some of that. All right, so I wouldn't consider this a full lecture on all the information, but again, spend time just looking at the trends of the world population, again, establishing what a society is, what the needs of a society are, and the environmentalist paradox as is attempted to be answered by agriculture's grand challenge. In the next presentation or PowerPoint, you'll have slides on food security, and you'll begin to see some videos and articles that are very, very thought-provoking, I think. All right. Thank you for listening. Hopefully you learned that you can pause or fast forward me through these points as I continue to hone my computer lecture skills. All right. Have a good morning, good evening, or good night.